Hello friends, I am GK Kate, delivering about that length computation of different elevations on a vertical photograph. This is the part of aerial photogrammetry. Now, what we explain of that computation of length of that particular terrain value elevation. Okay, let's see we here that is ground points A and B having variable elevations. Okay, this is A point, this is B point on the ground. Okay, then this is the photograph. Okay, this is the photograph, same coordinate points having that A and B. Okay, A and B. This is the O is that exposure station, F is that focal length, H is that flying height. Okay, and from that visual edges, when we join, this K point designates as a principal point. Okay, then what about their coordinates? Okay, these are the suppose that A and B. We have to compute this length of projections A and B. Okay, so that same ground coordinates here, that is the from principal line or principal point, this is principal ground point. Okay, xb, there is a xb, yb, there must be yb, that is a photo coordinates. Okay, then xa, this must be xa, then this will be ya, this will be ya. Okay, now what about that assumptions and let terminology. Okay, let terminology. What about, let we assume that A and B having the ground points having elevations HA and HB about the datum. Let's see here, this is the MSL ground level, and this HB and this HA having datums of that particular elevation ground points. Okay, then what about that if you consider that from similar triangles? Okay, what about that triangles, it must be, you have to write from these similar triangles O small k upon O capital KA. Let's see where is that OK upon that OKA. This is triangles. Okay, must be similar to that XA upon XA, that is capital XA. Okay, equals to YA upon YA, and equals to, that must be focal length upon difference between flying height and that elevation at A. It must be F upon H minus small ha. This is equation number first. Okay, then also you have to consider that secondary triangle from OK to that OKB. Okay, what about OK upon OKB is equals to XB upon XB is equals to YB upon YB equals to that focal length upon difference between flying height and elevation at B, that is F upon H minus HB. It must be secondary equation. Okay, then hence we have from this 1 and 2 we have to write that general equation XA is equals to H minus HA upon F into XA. Okay, and similarly from that Y coordinates, that YA is equals to H minus HA upon F into YA. Okay, so again that XB is equals to HA minus HB upon F into XB, YB is equals to H minus HB divided by F into YB. Okay, from this XA, YA, XB, YB, we have to write from that general equation the coordinates between X and Y of any points at an elevations are X into H minus H divided by F into X is equals to into, then Y is equals to H minus H upon F into Y. Okay, sorry for that. X is equals to difference between flying height and that elevation of particular point divided by focal length into X. Similarly, that Y point is equals to H minus H, that is difference between flying height and that particular elevation divided by F into of that particular point Y. Okay, so from that we have to consider and we have to calculate the length L, capital L, between the A and B okay, of the ground points of that particular ground points can be equals to under root in bracket xa minus xb bracket square, okay, xa minus xb square, okay, plus, okay, in between that addition plus in bracket ya minus yb square, ya minus yb square, that is equals to that particular length. So L is equals to under root in bracket xa minus xb square plus again second bracket ya minus yb square, okay. So this particular length of particular computation of length of that aerial photogrammetry of that particular uh, vertical photograph, okay. So let me consider that this is very helpful information for you have to calculating the length between that two ground points of variable elevation, okay. So friends, we stop here.